Holy crap.
Okay, now we are
Oh,
again,
geez. That whole
again.
long spiel was not recorded.
That
Crap.
was, but that so far we've talked sci-fi and
Well,
American
drinking, right?
jurisprudence.
It wasn't compiler related, so it's okay.
it's a good
So
thing
you were
we
giving this
didn't.
talk about performance, and I had one of those moments that's like relearning the lesson you've learned 1,000 times,
Yeah.
that you should actually measure things.
Yeah. Uh-huh.
We're
Uh-huh.
working on the system that's doing code scanning across every PR that ever happens for thousands of repos,
Yes. Okay. Uh-huh.
and replaced some of the rules that we had been clever about. Oh, you're looking for password or passwords, and you do a bunch of like this, but it could also have an S on it. And
Uh-huh.
we replaced a bunch of these signatures with just string we want to match, or string, or string, or string, or string. And our regexes got about 20% longer,
No,
but the
there's your first
runtime got
mistake.
considerably shorter because whatever the regex compiler is doing to figure out how to match these
Mm-hmm.
17-way ORs as fast as possible was significantly outperforming our little hand reasoned common
Gotcha.
sub-expressions.
Mm-hmm.
And I was wondering if anyone had worked on the sort of regex compilers, common sub-expression finder, like what are the tricks that these regex compilers are doing that they're able to do significantly better job of compiling the
Oh.
ORing of 17 strings together than my
Trace.
eyeball?
You go read the theory papers. If you have any sort of commonalities somewhere, they can check the commonality parts first. There's
Trace.
lots of hacks. I still claim
But it's got to be doing crazy things like, oh, if this bit is set, then it didn't match.
well, you want to get a cache line and a pop. So back in the day, it
Yeah.
wasn't cache, it was bytes, but they would jump bytes at a time. Like if your regexes have some minimum length, the expected smallest thing you'll get is some number of characters. There, as a minimum, they're going to jump that many characters at a time as they walk through the file. Um, Kind of made sense in the 80s, 70s, 80s, 90s. Today it's cache line at a time, and then you'd rather use SSE like ops, and then you can
But
pick
I
out.
definitely learned don't be clever. If you need to
Yeah,
match 17 strings, just put
yep.
them all together, join them with ORs.
And Matt's already got the link. Yeah,
They're strings and not patterns, correct?
he said patterns because you're probably adding S's on the end of people's requests. Let's get the plural. Did you what
Do the
you Aaron? You're matching
Yeah, the
strings?
basic answer was we were switching to longer but simpler patterns.
Yeah,
uh
okay.
patterns not so they're
So
not like
things like
one
if you have
word?
an enum, just OR all the enums together.
Oh,
Because I know there's tricks you can do if they're like strings that are not patterns, but I don't know. There's a lot of ways to optimize string search.
yeah. And it's a
Because one of the things we've been playing with, one of the nice things about LLMs is you can
yeah.
check the next token that's going to be generated and say, will this token make the regex go false?
Yeah.
And set the probability of all tokens that will make the regex go false to 0.
What are you getting at here? I'm missing
And
something.
then you do your softmax and you get an LLM that literally cannot generate any string that does not match the regex so far. And it's
Uh-huh.
generating one token at a time, but it's generating one token at a time while not doing anything that will cause it to violate the regex.
What is the goal here? This sounds amusing.
The goal is to force it to output data that is valid inputs to the things that you're trying to parse.
Okay. So
You
this
want
is
it to produce things that you know will parse. You know it's
like I
being
want to
parsed by a specific
like,
regex. So you say you must output something such that it completes this regex and all of the groups have a thing in them.
so like it produces valid C output, like any of the C fuzzers, except it's an LLM. Fine. I was like, what's the end goal? Okay, it's producing something that matches a regex.
Usually the
Repeat.
end goal here is extracting semantic data from freeform data. So I say, here
Ah,
is a PDF of somebody's resume.
okay.
You must output a field that says the address is this, and you might output the field that says the address is unknown, but you have to have that field.
Okay. All right.
And you're going to give me a thing that I can then parse and stick into a SQL table and now do much
Gotcha.
more rigorous searches over the things
Right.
that were freeform text.
Gotcha. Okay.
And if I want to make sure that my output is a row that I can stick into my database and that each of the sections is a thing that can be parsed from a string to the appropriate data type to go into that
So
row.
this is a fancy way to inhale semi-structured data
Yeah.
and make it structured and hope that he doesn't
Yeah. How
throw
to
any,
extract
right?
structured information from unstructured data.
Yeah, yeah, and he hope he doesn't throw anything useful away.
And our first pass at this was just like tell it to write a JSON object and then parse the JSON object.
And like this was fast or performant. You have some large count of these. Not resumes. You don't have enough of those, but or are you doing this on
We have a
resumes?
lot of resumes.
Okay. No, but they're not so many that you'd care. Because when I say fast, I mean you have to have billions or trillions to like care about speed. If you got
Yeah, so
millions,
I'm going to go back to currently working at LinkedIn.
okay,
People upload a few resumes to LinkedIn in a given day.
it happens. The LinkedIn, sure. I guess I'm going to go there in a couple weeks. I'll go ask them how
Yeah,
many resumes do you
repeat
guys get?
repeat the announcement. So it's
Oh yeah,
recording.
right. So, Coffee Compiler Club. Why am I doing here? Okay, fine. We failed on the recording button. Here today, talk about compilers and language runtimes, and I had a whole bunch of non-compiler things that I thought I was being recorded and it didn't. And everyone goes up on YouTube in a couple hours, maybe whenever I get to it. So last week, I spent the entire week in jury duty. I'm just going to do the really, really short form. It's safe to say here that mistakes were made, but it was a fascinating learning experience about American jurisprudence. And the dude got every opportunity for the fairest possible trial, and he just fucked up earlier. Now, at the trial, he had a decent lawyer, and it all went fine. Everything normal, normal, normal. No Hollywood moments. But the dude had made some mistakes, and no one was hurt, which was an amazing, total miracle. No one got hurt. Okay, done with trial. Um, And the other one was I'm talking at LinkedIn
Yeah.
about simple as growing a language. And I'm kind of amused because, I don't I consider simple not yet usable as a language because it lacks a real reasonable external compilation module link system, which is in progress and is well along. And I triggered another bug. One of my non-deterministic inlining bugs has risen its head, and I'm like, it shall be deterministic on the optimizer 100%. And so choices of inlining or not will be deterministic. And I got a non-deterministic piece, so I need to go run it down, and that's sort of where that's at. I guess there's more on the I now have last week's little vibe coding got me to the point where I'm now have some code which will go hunt the expected external search path for missing names, and if finds will open an ELF file and suck the name out of the ELF file, and then link against it, and I might do essentially, excuse me, some amount of link time optimization here, or it'll be I will inline as I compile against an external source, and then I'll have to have a check later that says that still a fast check later that's still valid when you link against it, which I'll probably do with some fancier checksum. So like in C++ land, you'd have headers if you included the header from over here, you got to inline the header bits. And then you had to check later when you're linking that you still have the correct headers. If somebody changed that module over there, your make utility, whatever, make, groovy, Gradle, whatever, does the right thing. That's the kind of stuff, except instead of a header being split, it's all the same code. And I just open that object file over there and parse out the object bits, but then I can inline them over here and optimize them. But then at link time, when you fill the final binary, I'll confirm that you didn't change anything on me. So there's a thing that's in progress. It's
Is
well
the
along.
link in the doc for the talk the right one?
Well, let's see here. Let me go. I haven't pulled up the doc since I started talking. Hi, yeah. I have a Theodore clearly filling in the doc, including the late start. So the doc's URL ends in like h1-4/edit tab, whatever, and that's different. So it's the right doc.
No, I meant
So
the one
yeah,
for
I'm going
the
to talk about
talk.
growing simple as a
You said
language.
South Bay Systems. I wanted to make sure that South Bay Systems
Yeah,
.xyz was the
South Bay
right
system.
thing.
Yeah. Um, and they said SSA is okay. Maybe put a refresher in. So I'll probably do one of the like the easy SSA, half easy SSA, and then half simple, and go back and forth between them as I
So
fill
this
out
is
the
a
talk.
compiler's talk or a language design performance talk or
Guy said basically compilers like talk to a bunch of folks who have, decent knowledge all around. Let me go full thing up because I was kind of surprised too. Um, Working on time. You see here, da 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 da. Da. You could we left open the topic open, but you could do say converting the simple series into a sea of nodes flavored growing a language style talk would be cool. Uh, Talk more about AA, and I'm like, you probably don't have enough type theorists involved for that one. Yeah, it's an hour long, so I'll probably do 45 minutes and 15 Q&A is the standard. If I squeeze an easy SSA in 20 minutes and do 25 on simple after that, and then that'll be 45, and we'll go from there. But I said South Bay Systems. Yeah, South Bay Systems talk. So I haven't hunted down their website to see what it says, but there should be a talk coming in the end of April, so a month away. I see you looking hard at your thing there, your monitor, looking up South Bay Systems. Okay, fine. So maybe that's
but
all
yeah,
of
that Guy
the
Steele talk, Growing a Language, I still think is one of the best programming languages talks I've heard.
okay.
He
I didn't
really
realize there was
focuses
a guy
on.
steal connection. I should go now look that up. So
Oh,
like
I assumed that the Growing a Language style
half right.
talk was a reference to Guy Steele's Growing a Language talk at
when I
Uppsala.
was at Oracle, he was two doors down, and actually, it was just Cameron that was between me and Guy. Guy was an interesting guy.
Yes.
He is an interesting guy.
Yes.
But he talks a lot about where things should live and making arguments that you don't want all these weird kinds of numbers to be part of your language. Like, should complex numbers be part of your language or
Oh,
should it be in the standard library?
I see.
And how do you
Yep.
build a language such that the language is very extensible and I can grow it and I can get the language to do the things that I need the language to do,
Yep. Yep.
but it also still sort of holds together and that the syntax looks smooth.
Yep. Has something. Yep. Yeah, I'll throw that together.
Um,
I'll go reread that. It's been a long time since I've certainly seen it. It's just been a long time. So I'll go look at it again.
and that was always the joke about Lisp was that a lot of languages spent a long time trying to get proper use of parameters and organizations and things to make library code feel like native code. And Lisp just solved the problem by making all of the fundamental parts of the language look like the library code.
Well, it'll look like itself. It's because the only
Yeah,
parts you got is parens. So everything looks like parens.
you know, if there's no plus in your language and you have to type add open parentheses a
Yeah.
comma b close parentheses,
Yeah. Yeah.
then suddenly all the library adds look just like the native
Yep.
one.
Yeah. I'm not there. That's too much for me. I'll
A
take
dot
my operators.
equals open paren b close paren.
Hmm. I'll take my operators. Thank you.
The
There's
other
something
day,
How
I
do you
did
do
without.
operator overloading in simple?
No, but if I end up morphing simple into AA, it'll pick it up. Like I did all the work to make it possible to do operator overloading. Like I know for me, the
I was
right
gonna say you
approach
spent a
now.
lot of time thinking about operating overloading in AA. My understanding was
Yeah, and
simple
I
did
thought
not
that was
have that out of the
I'm
box.
I'm happy I did that. It was a lot. It was a good strategy for solving the problems of the in Like everyone who does primitives and operators always has this weird tension of, I want to auto promote ints to floats. I want to have operators that add ints or floats, but not an int and a float, but I'll just auto promote. And that always felt very clunky to me. Um, and as soon as you go to overloading, where you're allowed to change the semantics based on types, then you have all these rules of do I promote or do I not, and they're all like arranging around with, you get Java, JSON with or JavaScript with promoting strings to ints or ints to strings, and no one can tell what the hell's going on. And I kind of felt I got a good answer, not coded in Anger or in large, so I can't tell for sure, but I think I have a better answer there.
Because that's the growing a language thing that we talked about years ago at this point with AA,
Yeah.
was what do you do with the syntax of AA to make it possible to, as part of the language, have tail call optimization? And then as part of the standard library, write the for loop
Oh,
and have even things like for and while just be library code.
I did that with AA, and I never got the syntax as nice, but it wasn't far off. I had a bunch of loops for AA that I presented on the show on this channel at some point. I probably dragged them up. I know exactly where they are. That demonstrated reasonable looking for loops, and it's basically for was just a local variable. It had been assigned a
Yeah, if you've got
function.
that convenient, I think it'd be interesting to
Yeah.
share the doc and go through the like,
Let me
what does
go
it look like to have for and
find
while
Google
in the
Docs.
library?
I
So
might be missing something, but I don't see why someone wants a for loop and maybe an if statement to be part of the like
the
the standard instead of the library. Or I
right.
mean,
The
instead
question
of the
is
compiler.
how
Embracing minimalism.
yeah how
Well, it's a question of growing the language. Python got itself into trouble between Python 1 and Python 2 because it needed to change syntax in ways that broke stuff.
so I threw in
If you
the
can get
docs
everything
here.
into the library, then if you want the new for loops, you just import for from Python 2 and you can use the
Yeah,
new
you
style. Like
want a different iterator syntax or whatever.
the
So
theory is that you can grow the language over time more easily and you just stop using the
I
things you
see.
don't like because they're just library calls you don't call.
I see.
so here is a for loop I've written, and it says pretty obvious, just count I up to n. So missing here. Let me throw some missing in here. So I equals 0. Um, is it obvious what it's doing? Everyone understand what's going on here? So the
Yeah.
actual implementation is for is simply a variable to assign in the library at some earlier time up in the library here. For is
Does
equal to
does
something.
the I need to be -1 in this case?
Um, oh, to start with? No, it's going to use I for 0. Oh, I see. Yeah, yeah, right. So there's some discussion here about where the plus plus goes, and I don't have the edge cases totally cleaned out here. Um, there's this version which I don't like. And then there's that plus plus version I do, but then I comes in at the wrong sum point, which I'm with you on. And actually in here can really be array length. So you might write this more like this, except we have to deal with the I value being initialized correctly. So not completely syntaxically cleaned in every way, but the actual implementation of for here is just a function call which takes two thunks. Here's a thunk. This is a function. This is a thunk. This is an anonymous function in AA. It takes no arguments and it returns a value which is a Boolean. And it has two externally valid values, array and I and array there. I missed it. And it has a second one, right? And then the while loop has a slightly different thing here, but we're close here in for loop. So here, the for loop is defined as a function, which would be an open paren. It
Right.
has
So
the
for takes a thunk
yeah.
and returns a new function that has partially closed over that thunk.
Well, for takes. I can curry this expression sort of generically. You curry anything you want in any order, but it takes a test in a body, and the test says something like, "I'm going to run the test as a function, so I'm going to run the test." And if the test, so let's see, how do we do this here? You're gonna have a question mark colon here. If the test, I'm gonna run the test, which will increment I as a side effect, return me a true or false. If the test is true, I'm gonna run the for loop on the test, and I want to say I'm gonna run the body. Let's see, test, comma, body, and I'm missing where I run the body. So we're just going to put the body happens here, and then you can run the for loop. And if you fail the test, you're returning, I'll say returning zero here. So this is like a wimpy version of the for loop implementation. The actual one returns the last value of the body if the test fails. So you can get an exit value from a for loop. And there's another variant that says if the body returns false or true, then you'll exit the loop. So you can get for loops and you can get while loops and things like that with minor variations. But the general idea is the keyword for is just a normal variable. It takes a pair of thunks. It takes one or more thunks. For takes two, while takes one. You get to take a thunk. You're going to evaluate one of the thunks for a Boolean, decide to exit or not. And if you don't exit, you're going to recurse. And that's your loop, the tail call elimination. That's your loop. And then you run the body if you pass the test. And the body and the for loop doesn't have a forced exit, so it just runs the body and then it loops again. So that's kind of the
Now,
notion of where,
in my mind, canonically in the for loop, I goes out of scope at the end.
yes,
You don't have that here.
that was the only reason I couldn't get sort of, I had this sorted out for the -1 and the 0. I don't remember what I did for it. I have to go hunt it up. But I couldn't get the I out of scope without syntax. So the simple parser does a for, it's just like C, I less than whatever, array pound, I plus plus. That is syntactic sugar for open a scope, int I equals 0, while blah, 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 I plus plus less than array. It's not, you have to put the plus, the minus the int here, while I less than array pound. Open another lexical scope for the body. Now you have the dot dot dots, and then you do the init, the increment code I plus plus, and you close the outer scope, and that it exits the scope for I. Right, this is bounds the scope for I, which I couldn't do in AA without having some other syntactic help. So I implemented these for and while and the variations thereof in AA as standard pieces of library code that you could override, whatever, except that you had to have your incrementer outside the for loop. There are also for loops that do more like
So let's say I wanted to have a for loop that took in 3 arguments, init, test, and body.
you just make another for loop that adds a third argument here, and operator overloading, whatever the function overloading would figure out you wanted the 3 argument version instead of the 2 argument version, not a problem.
But what I want is to say, hey, when init finishes running, give me a scope. And then
Yeah,
I
I
want to
don't have
say execute test in the scope, and I want to say execute body in the scope. What you need is a syntax for essentially call in scope, execute in scope.
um say that again. So
The reason that your for loop can't just have 3 bracketed bodies, one for the init, one for the test, and one for the body.
you could have 3. And
But your problem
that'll be
is
even one of the
that the
ways I
stuff that
solve
is
the plus
in
plus.
scope in the init is not in scope in the body
Oh yeah, right. To make that work. So right. So the
because they're
issue here is
separate
that
funcs. So what
yes,
I want to know is what would a natural AA syntax be for I'm holding a scope here and I would like you to execute this thunk, but I would like you to execute this thunk with this scope sort of using din at the top.
yeah, you have to add a scope. Like variables in AA come and go with scopes like your normal scoping rules. So let
Right.
me see if we get closer to what
Right.
you're.
What I'm looking for is a syntax for scoped injection in a call.
Yeah, there is no such thing, and it can of can't be for the language semantics, but I can add a scope right away. Here I'm added a scope, and now I want to put a test and a body in here yet. So somehow I want to have a test and a body. And that I can do by returning a tuple of a test and a body. And what really I've done is I've just made a whole lot of thunks. So this is a thunk that makes a scope. Scopes and thunks in AA are synonymous. They're the one and the same. And I put a variable in it, which is now valid and visible for both test and body. This is a tuple returning a pair of functions. So I have a bunch of extra parens as a normal syntax for writing a for loop. There's a bunch of extra parens. But if I were to write the above loop where I've bounded the space for I, let's go ahead and put this curly to the left here. I say I equals 0, open paren. Okay, now I want to say test here. Sure. Test I plus plus is less than array length. And then it's a tuple, so I'll put my curly. And then down here, I'll say array sub I. Yeah, I equals whatever, I times I don't care. I'm making, something up here. And I got to close the body call, and I have to close the tuple, and I have to close the extra scope. So at the expense of a bazillion more pareni things, here is a valid AA syntax that gives me a scoped bound for I, hides the scope for I. And I don't like that, although it's
What are the parentheses
technically,
doing?
well, okay, so for is just a normal function. It takes a thunk. He evaluates the thunk once. That thunk returns me a tuple, a pair, that's this pair right here, of a pair of thunks. He extracts the thunk for the test and the body, and the for code does this, and then he begins running test and body until the test reports false. But because of the extra parens here, curlies, I have a scope that bounds the lifetime of I. So in this case, I's lifetime is just limited to this body, and then it goes away. So how is for defined here? So this is the high level description. This is a sample use from the above loop. Here is the definition for how I'd write such a for. For is assigned as a function which takes a thunk, which call it f, which when I run f, it's going to return me a pair of functions. So I'm going to do syntactic breakdown. Test comma body is equal, oops, body, God, I can't type today. Body is equal to run f. Okay, so let's go ahead and put this on another line. And
And
I have to
body
do,
has access to I because of closure rules.
yep. And then down here, I have the whole the loop I wrote above where you just keep calling recursively if test passes, right? So if test, so it should be test is run, and if this is true, then I'm going to go get it. If it's false, I'm going to exit. So I'm going to use a little different syntax here. That's the if false exit with a 0, and then the up hat means return, early return, exit. Else I'm going to call body, and then I'm going to call some thunk, which I haven't written here, that preserves test and body. It's not, you don't call it for again. So I need another internal function to make the internal looping work. Because it has this one layer of indirection, it has to pull out test and body. So there's something here. I don't quite have it yet. I need to add another recursive loop to get the tail call to turn into a function loop, to a loop. But it's the same basic notion, except that I've added another scope layer so I can hide I's lifetime. And that's kind of baked into how the AA language design works. The whole theory there is it's all just functions applying functions on functions, except they all inline perfectly, and I know totally how to clean them completely out and turn it into a complete C style, Fortran style for loop in the IR underneath, and you can get all your performance back. So there's nothing in here that can't be just completely unwound. And the only real trick is that in order to hide the scope of I, have it be narrowed, I have to have a syntactic hack in the parser that stops and says for is special. It introduces a scope, and totally simple does that. Simple says, oh, for is special. Let me introduce a scope for the test variable. And he does that, under the hood in the parser, fine. AA's parse rules here are very, very simple. You look up anything, including for, I, array, everything. You just look it up. It's a variable. Take a look up. What do you get? Oh, okay. I got a function which takes functions. Fine. And then, you start parsing the next thing. Open curly. Oh, you must be a function. And on you go. So the parsing rules for AA are super simple. And the implementation of keywords can be almost entirely done as just normal variables with this one caveat. So if I go to simple and I get it cleaned up to where I like where it's going, I might start looking at allowing this kind of stuff. Simple does have anonymous functions. I kept that piece. I didn't do operator overloadings, but I could. And the deal I have right now is the way I solve operator overloading for AA really relies heavily on Hindley Milner typing. And simple shall not have Hindley Milner because that sort of runs counter to being a simple compiler.
What is Henry Miller?
Hindley Milner, bidirectional functional typings. It's the classic lambda calculus, typed lambda calculus. Are you familiar? I can do the 10-second tutorial.
I'm just trying to understand how that relates to function overloading.
Oh, it relates because it's how I was solving the problem of overload resolution. So I could do an overload resolution in simple using not Hindley Milner, but it has its limits. It's an overload resolution. Hindley Milner is a stronger typing system. It allows you to infer types almost entirely over the whole program without any typings added at all. Do I care? Why would you not do that? Well, you obviously want typings in places because it's super good for documentation. What the hell you think you're trying to write here? But if you're in the middle of an expression and the expression has a whole lot of variables that do all kind of funny stuff and you're not sure what the types of everything is after you've added and exported. So imagine you're in JavaScript. You say A plus B times C plus D times E and goes on. It's some complicated mess. Okay. And you think, oh, that's easy. But what if, A is typed as an int and C is typed as a double? What are the rules on expanding? Well, it depends on what B and C are, unless you're JavaScript. And then, E is a string. And by God, that string will cause some other things to become strings. And some of the math is in floats, and some of it's in ints, and some of it's in strings, and some of it's strings times floats times ints, or whatever the hell. And now it's complicated. What are the rules? Okay, so what I did in AA was say there's a straight up I'm just using Hindley Milner to do type analysis and infer what all the types are with a very well understood type theory. And then because it's a well understood type theory, you have an easier answer, or at least an easier time in my head of deciding I know what the types are. That tells me which operators do what. Like that add operator, is it string concat? Do I convert you to an int to a double and do double add? What are the rules on the string concat there? And now I say the rules are, I'll do Hindley Milner on you. That'll tell you what all the types are, and now you know what the operators do. And there's a whole lot of stuff that Matt's writing, and I have to back off and check.
I don't know how good my mic is. Can you hear me?
You're sounding good now.
Okay, so a strong recommendation for a paper or a talk is Olin Shiver's Anatomy of a Loop, a story of scope and control. This is extremely relevant in the context of Guy Steele's talk, Growing a Language, because it is exactly the story of how did this work out in Lisp versus Scheme. And even though Lisp had a lot of loop macro packages, it actually took a long time for Steam to have anything equivalent. And Olin Shivers explains the reason for that, and what's interesting in the compiler's context is that he proposes a loop macro package that is based on dominance scoping. And if you recall, the main difference in the compiler IR forms between CPS, continuation passing style, note the linked list obviously, and the SSA form is exactly the difference between lexical scoping and dominance scoping. So this paper touches actually a lot of extremely interesting ground. Highly recommended. Anyone who is interested in programming language design, compilers, or loops, you will find this paper one of the best papers possibly.
Well, I have to go read that.
I'm not familiar with dominant scoping. Is there a one-sentence version or not really?
Not really, unless you think of dominance as in dominance trees, dominance properties used after deaths. Does this ring a bell? Like, there's several ways of explaining that. I just went through them in bullet points. If one of them clicks, then you got it.
Yeah, okay. I'll have to go through that one.
It's the same dominance as in the dominance property of SSA.
I wanted to
as in every dev that dominates the use of the variable. So if you have a basic block and you have a later basic block, then you always have to go through the basic block with the dev before you go with the basic block of the use. Which sounds really useful, right? Because otherwise you would have uninitialized values, which are not really values then, and a lot of reasoning breaks down. So if you have like a diamond basic block structure,
I see.
A gets one on top, and then when you read A, as long as you read in a basic block that is dominated, you know always that it's going to be one.
Essentially, every time you have a dominating block, it opens a new scope.
Yeah.
But that's not going to tell me the difference between CPS and SSA yet, which is
fine. And CPS closer to the lexical scoping. I can post a link. It was discussed actually in the Lua compiler context. I'm gonna post that here to find it.
So
find a good link for Ryan on Hindley Milner. I've used the Wikipedia page, but it doesn't give you the sense for it.
I'm looking at this and I can already tell this doesn't seem like the best idea, because like the way I do it is every function call has inputs and it has a return type, and that's overloading is complicated, but it's like, okay, pick from the overloads which overloads are candidates, and then you have a ranking system, and there's a concept of better fit and worse fit, and then
let me see if I can change your mind, not change your mind, see another way. Suppose I have defined, okay, now how do I get the thing to not do that? Okay, so I define operators by simply saying the operator syntax with underbars where I'm going to put arguments. So that's an operator definition with it's a function with two arguments, X and Y, and somewhere in here I call the primitive add. Primitive, close enough, int add. This is a function because it has two integers, has to have two ints, it's defined on two ints. And then I wanted to say I have another operator. See, he does a weird thing. If I backspace and go forward, he gives up trying to auto things. Or I'm adding my doubles or floats or whatever you want to do it. Here, y colon double. And I have a, dot, dot, dot. This is the, primitive, double add. Okay, and I could do the same thing for strings. Oops, little string. I'll do what little string? Cat, yeah. Okay. Now, if I'm adding a plus b, which of those function calls should I call here?
So my language is like, okay, I'm going to look for a dot operator plus.
Yeah.
So what is the type of a? Look for operator plus. If you don't find it, you look for b dot operator plus right hand side.
Okay, so that's what I'm doing. Except I have this case. A is pi, and B is 17. An int.
That would mean that your checking Ryan is always left associative, correct? If you're trying first the left, but it checks first A. That would mean that what if A has plus and B has plus, but they mean different things.
Well, it's going to look for A. It's going to look at the left-hand side first,
That
usually.
That's what I'm doing with AA as well.
That is left associated. So it's always associated.
That's the
with
typing. That doesn't tell you associativity rules. Like if I
think it's both.
I'm sorry?
I think it's both here because you are always trying to resolve the left symbol first. Does it have?
Well, okay. Suppose you have this.
Mm-hmm.
Now you come through with A, and you look up and you find I have a plus for A. What's the right-hand side? I don't know yet till I type the right-hand side. What's the type of the right-hand side?
So I think that would be interpreted like this one, like first the A plus that would be.
Yeah, but okay. So now I'm going to Ryan here. What do you do? How do you pick which type, which plus for A, until you've also evaluated the rest of the expression?
You don't. You evaluate the other part of the expression first.
Okay.
In order of operations.
Okay. So in general, you're building up from the bottom up, and at some point you have to resolve what B times C is to get a type, so you can resolve what the plus on A is. Is that correct?
It's just gonna evaluate B times C before it tries to type the add operation to a specific operator.
Okay. Overload. So you're hanging on to the unknown. I don't know what the overload is yet until later.
Well, it's going to evaluate. It's going to say I'm in the plus operator, evaluate the left side, evaluate the right side. Okay, now I have both of these. And now what types are they?
All right. The reason I'm pushing here is because imagine I just make this expression like convoluted and have internal function calls and all kinds of other things. You're going to stall on evaluating the overload for the A plus until you finally get whatever the right-hand side expression is, which could be a huge long thing.
Yes. Okay. That would be recursion.
Okay, and if I get into self-cyclic operations here, when do you resolve? And the reason I'm bringing it up is because Hindley Milner gives a strong theory on how and where that resolves.
You can't be in a cyclic operation unless your expression is infinitely long.
Well, okay. So I get to do this with AA, which maybe doesn't make any sense. And that would be a for loop where I do something with AA, where I add into myself. But you're saying, oh, I get an initial condition, and I have an ambiguous initial condition on purpose in AA, which doesn't help here. I'll give you an example, but it doesn't really help. So while random, let's see here. A plus equals something ambiguous. 1. No, it's not going to be ambiguous either. And this kind of a thing
because you don't know if you overflow. Is that an int 8? Is that an int 16? Is that an int 64? The one you can't teach you what the numbers are.
You can't assign variables as numeric literals. You have to type them.
So in this case, 0 is a special, meaning it could be a null pointer, and this B could be a string. And it could be an integer or a double. So 0
does this 0 have to be like I64?
Yeah, I didn't type it. If you did that, then you would get an integer add very clearly. And it would be, and then B has to be compatible with an integer add.
Yeah, I don't allow that.
Okay. Yeah, I'm pretty sure Hindley Milner, as soon as you're not typing everything, then it steps in. If you're pre-typing everything and the user has to say everything, then you're just verifying it, so you don't need the full Hindley book.
Well, you can also auto stuff, but if you auto stuff, the arguments on the other side still have to have a type. Like you can say auto x equals y, and then x is the same type as whatever y was, and that's fine. But you can't be like typeless variable equals typeless variable or something like.
Yeah.
I don't know. You can't just declare a variable not to have a type.
You can do that in Hindley Milner. That's kind of the point. If you look at some of the functional programming, they'll get large, complicated expressions with no types in them at all, and they'll resolve to a single, well-understood type when the typing's done.
Yeah, that is something I explicitly am going to definitely reject because that is a very slow way of compiling programs.
It is not slow. Way too long. No, sir. No. Hindley Milner is not slow. It's quite quick.
It's potentially very slow.
No, it is not potentially very slow. It
Yeah,
is
it's not.
quite quick. There are a handful of times where you can force very weird cases where the time blows up, but any normal coding, it's essentially linear with low constant time. It's no more time that takes to parse the text.
It's
And so
not linear in the worst case.
there are
Not
pathological
linear.
cases that are exponential, but they never, ever, ever, ever would happen in real programs. Ever. Don't
Right.
worry about it.
I think it's. I thought it was
terms, don't worry about it.
right. Yeah.
I was under the impression it was
the
cubic
real
in the
point is,
adversarial
it does not
case.
happen in real programs. I can write test cases of code that you would never in your life ever want to write or imagine anyone would want to write. That would cause it to blow up. But in real code, right, it's fast. And as I said, it's really fast.
I just don't even
constant
see
factors are tiny.
I don't even see the use of it, honestly.
It's because you haven't tried programming it. These are
Auto
bad
keyword?
examples. Go look at Scheme or any type lambda calculus. Sorry, not Scheme. Any type lambda calculus. So ML, Haskell, OCaml, and look at what it is. The instant rejection is a red flag, sir. There is a whole nother universe over there. It would do you well to understand how that universe works, even if you don't want to use it on a normal daily basis.
I don't like to do algorithms so I'm trying to make a language that compiles fast, and part of that is not using algorithms that are, n squared or n
right.
cubed.
It's not, it's in practice, it's linear with very low constants.
In practice, it's fast. It's just as fast as you checking statically typed.
Yeah, exactly.
I also feel like it makes the language more confusing to read if it doesn't have types.
That's a key point, and that gets into the heart of what people who write these languages on a daily basis feel is the misunderstood tension. If you're in that zone, you love it. It works great for you, and you can write clear, concise, simple code that does what you want and is fast and efficient. Great. And if you're from outside that zone, it looks completely opaque and hard to understand, and kind of as a programmer, I encourage you to understand at least enough to see what the goodness is on the other side of the fence, because it's a real thing. It's a useful thing.
Yeah, so almost every C++ program I've seen, as it starts to get large, eventually gets to the point where someone wants to use a template.
Yeah.
Like, you really feel the need for templates in C++.
Templates are fine. Templates have input arguments, and then you determine what the result of an expression is based on what the inputs are.
No templates in the worst case don't stop. They're unbounded.
Yep.
I almost never find myself writing Python code and saying to myself, man, I really wish I could make a template version of this.
Well, you kind of do, because Python is like templates by default, right? It's the DAG type language, and just like C++, templates are structurally typed. So you are using templates all the time whenever you write a function in Python, unless you constrain the types. Like if you start with my PyStyle or whatever.
Yeah, Python
is the ability to have a language like AA, where in the places where C++ would reach for a C++ template, and the way you implement that is just don't type types.
Yes. Whereas in AA, you just write for the code. It would be polymorphic by default. The things with the Hindley Milner is it gives you polymorphism by default all the time. And then there's a way to make the polymorphic code efficient.
My language is something that people are probably going to hate, because you write a type, but it's not like the exact type. Based on where it is, like if it's a parameter, you can say int and then square bracket, but it doesn't mean it's an int array. It's actually an int slice, and it's constant. And if it's a return value, it's not constant. So, and it is array. So it's a little weird to a couple of people, but I like it.
So one of the things Hindley Milner does is it allows you to define what map is, where map says, I take a collection, I said array here, let me take a collection of A's and a map from A to B. And if I were to use map, it would evaluate. So here I have hand you some sort of string array and a function that takes a string and returns an int. And you can imagine this, I'm parsing a pile of numbers into an array of integers. And the string to int call is some library call a to I, right? But then map might also say, oh, I have some int array, and I'm computing an int to double, and you might call this square root, for instance, would fall into this camp, where I take an array of ints and take their square roots because I'm doing some stupid graphics library thing and I'm doing the Doom hack for square roots or something weird. Who cares? The point is, what is the type of map? The type of map is from an A collection to and a function from A to B. And Hindley Milner allows you to infer the type of map directly as opposed to declare it. And that's sort of the power of it, including
and differently at different call sites, right?
Yeah,
it doesn't work unless your like set lists and stuff are built-in types and not user defined. Like if you're in a systems language, I don't think this works at all.
This in every Hindley Milner type
this
language,
definitely works.
Yeah, this is exactly the poster child case for it working. At this call site here, A is turned into a string as a type, and B is a type variable is typed as an int. And this one here, A is typed as an int, and B is typed as a double. And that is the power of Hindley Milner. And you don't have to, you can write map directly without having to define a type for map, although you could also define the type for map. So here, A and B are abstract types. Yes, whoever's writing anonymous scroll, that's probably Theodore. It's a more powerful version of generics. That's its strength. That's the goodness about it. Anyhow, whether or not you love it or hate it, what I'm doing with it was saying I'm using Hindley Milner to do overload resolution because it gives me a very powerful version of overload resolution that works sort of with very strong type theory, fast and efficient, blah, blah, blah.
Does Hindley Milner make any strong claims that there's a single type to something, or could it track multiple attributes at the same time?
No. Hindley Milner
gives the term is Hindley Milner will find a principal type. That would mean a type that will, when you enter the whole program.
You cut out, Theodore.
Yeah.
Well,
can you hear me?
Yeah, you're back.
Hey, can you hear me?
Yeah. Yes.
Yeah.
Can you hear us?
Internet issues.
Yes.
So the principal type would mean that there is
one
a
of the things
type.
Okay, let Theodore go first.
It's not just saying this is an integer.
Aaron, we'll let Theodore go first.
Unique pointer.
No. Go ahead, Ken. We'll come back. Go ahead, Aaron.
We're having internet delay issues on all sides. I think it's Zoom latency. Yes, exactly. Everyone's right. We'll get the recording. Oh, the recording will be on my machine. Y'all will hear my relativistic. It's all relative. You'll hear my version of things.
Okay. So I've used C++ and I got annoyed by templates.
Yeah.
And I've used Rust and I got annoyed by, is this a mutable reference or an immutable reference? Or is this a thing that I'm lending, or is this a thing that I'm giving away? And I'm tempted to just throw stuff like that into a Hindley Milner-like thing that says, is this a mutable reference or an immutable reference? Well, I didn't label it, so you just figure it out. Or I explicitly say, no, this function needs to take a mutable reference, and now that's going to propagate out everywhere else. And now when I mouse over something and say, hey, I'm calling this function, and I mouse over it, my IDE can still say, oh, you declared it to be immutable in your function, and you passed it into a function that requires it to be mutable. That's a contradiction.
Yes.
But the mutability and immutability is sort of an entirely separate dimension of typing than the, is this an int or is this a float?
And
I don't know if Hindley Milner is going to get cranky at me if I start trying to do it on ownership attributes and mutability attributes and
it should be
bit
fine.
layout attributes all at the same time.
I've done this with Hindley Milner. You can go hog wild here.
But I think the danger is here that the principal typing can change the semantics based on what it sees fit. In order to freeze that, Aaron, you said that you will be manually annotated in order to freeze what you meant to be. But if you don't mean it, if the principal type can change the whole semantics. So that's probably needs consideration, at least to me.
It would be in my example down here with the map, if the types of str and int here were themselves type variables, and later in life, due to other things, one of them gets constrained to be either a double in one program or a slight change far removed gets constrained to be an int in another program, is what I think what you're saying here. The type inference has far-reaching effects. And that's one of the complaints people will have on Hindley Milner is the difficulty of understanding type errors because they reach so far. And I've done the Hindley Milner in larger programs, and the answer kind of comes around to if you start getting weird type errors, you need to start annotating types where you think it ought to be a particular type. And as soon as you annotate, the bug will move around because you're telling the Hindley Milner, no, this is actually here. You don't have to guess. I'll tell you. And so he says it's over there now is the issue, and it quickly narrows down to where you made a mistake. Yeah, here's Matt saying here is a one where they have affinity, uniqueness, locality, completely inferable, which would be Hindley Milner, go to town. And I was thinking that with AA, I could get some of the Rust own borrow things totally sorted out into Hindley Milner because I had done a bunch of other things with Hindley Milner in AA. So AA was definitely doing final fields, as well as readable, read write, mutable, whatnot. I was using a lot of time.
To be fair, in Oxcaml, they did have to extend this a little bit. So they are using constraint solving and they have to use inequality constraint because instead of equality constraint, because you may have things like subsumption in a sense. But they were able to do that, and they have both type and mode inference.
Okay. I was doing only equality constraints in my solver for AA. Somebody is getting hog wild here, but right, you can imagine adding more user-generated, user-defined types and using Hindley Milner on user-defined types. I think that would be entirely a safe thing to do.
Right. So this is my question. What if I try to do this and put that into a language like AA where there's just some type that is the type, and if I declared user-generated data as one of my types, and now whenever I label something as user-generated data, and I have this function that says, okay.
Right. And it has to
This is my function that explicitly takes not user-generated data and will blow up at you if you try to pass in user-generated data at compile time.
So I've been doing this in AA with type sugar. It's the name I've come up for the thing where you live within the existing type realms and you add some type sugar to force, like the difference between nominative and structural or duck typing versus not the duck. I can do this with type sugar. And now if I wanted to add some sort of user-defined type thing, I still need a rule on the transfer function. The function here that's typed as an int to a double, it's an int that does or does not take user-defined, and does it produce a double with user-defined or not? So there's some rule about transferring the type across the wire here. If I'm going to infer, suppose I have a mutability issue and one of my int to double requests consumes the int and one does not. So one must make a copy and one does not. Which one do I pick? Well, that's an overload resolution. That's Hindley Milner is good for that, but I still need
if I have int plus int, but I also have int plus int that's been tagged as user data.
Right.
Which of those is more specific is not necessarily obvious.
Well, no, you'd have to specify that as part of the language semantics.
Yeah, that's right.
Yeah. You need to have a specificity hierarchy of things, just like going from mutable to immutable, there's a singular implicit conversion needs to be. You could do it through implicit conversions. Yeah, you just
Yeah, I
implement
didn't do it.
this.
I did not do it in
Yeah.
AA with implicit conversions. I very specifically stayed away from those. So no implicit conversions because of such an ambiguity question. But instead, I said you had to define the different flavors. So you gave me an int with user data or an int without. You got an int without from the system. You gave a new
Right.
one.
But int that's been also tagged as user data
Yeah.
satisfies int.
And then I'd come through and say, at the overload resolution, there has to be only one that's allowed here. And if there's more than one, it's ambiguous and you get a type error. So if you have an int with and without, and you have a function that takes without, your question is, can I pass you one that has a with, and you're going to throw it away and get an answer back. So the canonical easy example here is I want to put metrics on my integers. I want to have gallons. I want to have liters. I want to have volume metrics or length that are meters or whatever, right? I mean, meters and liters and time is whatever. So I want to put units. And then I do generic math on units. And what do you do with the unit math? You throw it away. You have overloaded versions that say if I take a int in meters and I take another int in meters and I multiply them, I get a meter squared. And what are you doing with your types on the units? And I think there's a way to do that. But you'd have to add, for my case, you'd end up adding operators for int with a user-defined length and another int with user-defined length. And if you were to multiply them, you have to have an operator that produces an int with a pair of the length squared, the extra squaring operator on the thing. Or I almost surely throw you an ambiguity error at some point where he tries to take the output of that, do something useful.
But if I can have a free function and distinguish between borrow and lend.
Yeah, I don't know. This is one of these things where you have to go fight it out now. I started on the path of doing metrics and got pretty far and thought it was okay. Pretty sure I can do it with metrics. I never did it with borrow versus mutable. It seems reasonable, but I don't know that I can. Right, the length ones. This is Matt in the chat. C++ templates can do physical unit libraries. That I didn't know somebody was trying to do it with templates.
Yeah, this is actually pretty good because most things, this is worth reading. Most things on the internet, like 99.999% of the blog posts are going to be talking about stupid, naive stuff like, I don't want to add meters to temperature. This is obvious and you can do it in almost every languages. This is actually talking about more interesting things. How do you go beyond that? How do you also control the kinds of the things? Like maybe some meters is a kind of a length.
Right.
Maybe meter per second is a kind of velocity. Maybe it's actually fine to compute with miles an hour and meters per second, and you still want this to type check with some conversion. How do you make that work correctly? So this kind of, and most blogs and articles actually don't talk about this more realistic things. And in real systems, you actually might want to do that. So this is pretty good, actually.
I got something I liked in AA to go do the right things.
Like most things just talk about this first level, dimension safety, prevents mixing incompatible dimensions, but you can go far more than that, up to mathematical space safety.
I got this far to 2. I didn't do overflow precision loss.
Mathematical space also matters for things like time computations and calendrical computations. Like if you have a point in time and you add duration, you still would like to have a point in time. And that's actually a fairly interesting property to type check because there's a lot of errors in time computations that we can rule out.
Yeah, I have to say, of these 6 safety levels, I got maybe 3 with my hacking. Right. I got at least as far as this. This would blow up. I would certainly allow. Well, I would give you the inverse No, speed times time. No, I would give you the you would get the error here for you. The type for distance would be weird on you.
I feel like type aliasing gets you a long way here of just saying.
Yeah, right. This would be meters per second.
Speed equals meters per second of 100. Just make a new type alias.
Yeah, that's what that right. So that's what I did in AA. You would have to add a type annotation saying it was typed as meters per second. So because I wouldn't know from the number 100. And again, time would be, quote seconds. And then this math would not compile. And this math would compile, but your result would be meters per second squared, which the name distance is misleading because it'd be typed as meters per second squared, but wouldn't be distance for sure. That would show up as a later type error when you expected a length and you got an acceleration.
So if I'm in AA and I just say distance equals 105 colon meters.
Yeah. Yes. Meter would be a type that itself was a variation on int.
And I didn't have to initialize that type anywhere. It simply learned that type exists because I was using it as annotations.
No, I needed to have a type declaration here. I believe I ended up with a syntax that looked like meter is a assigned value, which is a type of an int. Now meter is a new way to say an int, except it's not compatible with anyone else's version of an int here. Temp's better one here. So meters and temperature can't be mixed, although they're both.
Can you say second instead of meter just for parallelism? That's hurting my brain.
Yeah. So second and meter can be are both integer typed, but they cannot be mixed.
And now I say duration equals 5 seconds. And length equals 6 meters.
Yeah.
And now we're going to make a speed divide operator overload that returns meters per second.
And then this one would blow up because divide doesn't understand seconds and meters.
No, but we can overload it to understand that.
Yes. So then you'd have to say divide, okay, you see back, is equal to a function which takes a length here, a length which is a meter, and a length which typed as a meter, and a duration, these are other names here, is typed as a second, and returns me blah, 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 and I'm going to cast you. So I'm going to do the normal math, len over dir here. I'm going to cast you to being of type, and that's not the cast syntax. What did I do for cast syntax in A8? I have a cast syntax, and this is not it. But it's going to type you as meters per second, which I don't have, so this has to be a new type. So I didn't automatically derive the physical units. I demanded that if you wanted to have another one, meters per second here was equal to a type of a dir, and I had some way to force. I don't remember now. I had a way to force that it would be meters per second as part of the type, and I don't have it. So this is not the correct answer. I'd have to go back to see my old notes, see what I did here. But yeah, you'd have to overload all your operators, and then you would just pick the correct set, and then because you defined your operators correctly, you get the correct answer out. So it's very verbose or something. It's very, you have to do a lot of writing here. So the standard library author who's defining these things would have to have a bunch of repetitious writing to go fill in all the details. But you do it once and walk away with it.
By the way, the representation safety aspect is also interesting, I think. Because one of the examples, for example, say you have your meters, right? Mm-hmm. And your representation is int 8. And then you change the unit to millimeters. That actually is unsafe because the meters can overflow the millimeters if you go from 2 to 2000 and you are using int 8. Whereas, for example, if your representation is int 16, then that works. So that's one of the examples I commonly don't see in the other units libraries. They don't just think about this at all. They just work with like with int8 always and ignore overwrap or use the language to, warn you to throw exception at runtime, which is stupid because if you can prevent this at compile time, then you should prevent this at compile time. I really recommend this post because it goes into those design issues that most people skip, unfortunately. And I think that's why most of those unit libraries are not useful in the real world, because they ignore those 99% of the things that you're going to run into. And it's just death by thousand paper cuts. There's a lot of things you have to get right if you want this to be usable.
Right. Well, as soon as you're using fixed point math or overflowing math, you've got more issues that need to be solved. And that's, of course, true for
sometimes you have to. Maybe you want to use int 4 units on your GPU, and integer 4 is exactly what you want to use.
Yeah, right.
If the library doesn't have your butt, then it's useless.
Computing device, the smallest possible drone control is going to have some int8 or whatever he's going to be using to be low power and lightweight for motor control. Yeah, they'll have all those issues. No, I didn't get that far with AA for sure. I was just experimenting with, I could do a named type and discover with overloading that I had a well-typed setup here, but nothing to do with overflows or conversions. So Ben, is there actually...
Pasts are always interesting
jerk,
because...
But snap, crackle, and pop are like follow-ons past jerk?
Yeah, it keeps going. Yeah. Right. And when you're really doing real physics, you've got it's to the second to the power of -6 because we've pulled in all sorts of other dimensionalities, and it'll cancel out when we bring in this other formula in here.
Right.
So no, these sorts of physics languages are just like, you want to do high school physics? Yeah, we can do high school physics. Or rocket science. Yeah, rocket science. It's 1960s, dude. Get over it. But if you're really going to do it, then you need a dependent type system where the units are a vector, and I mean a mathematical vector,
right?
Not a list, but implementation. You boil it down to a list, and then you do your canceling and stuff.
I remember the people at Waymo talking about how surprised they were that in order to get the best gas mileage, they needed their car to minimize not acceleration, but jerk.
That's interesting. You have enough units, similar enough vehicles that you begin to do, and enough data out of them. We begin to do fleet-wide math on things like that.
But it gives it a weird feel. I don't know if you've ridden in one of the Waymo cars yet.
I only watch videos of people screaming at Waymo cars to get out of the way because they've stopped and parked them in. Waymo cars misbehaving. Fine.
So I want to make a comment about the parameters and immutability and constants and all that. Don't know if it's going to be long, but okay. So you were saying earlier about when you change a function signature, some languages would just force you to change the signature all over the place. In my C++ code, or actually for context, in my language, everything is constants by default. And so in C++, I don't actually have everything as constants. I just like leave it alone. If I really want something as constants, I'll make it, but default, I don't bother. So one of the things I was just thinking about was, how do I change something to not be constant without changing it everywhere? And one of my thoughts was maybe if the function is private, I don't automatically have it as constant. But if it's public, it's constants by default. That's going to definitely be weird to a lot of people, but I think that will also not force people to like make a lot of changes if they just want to try something as non-constant, and it'll just be less annoying to implement. So I don't know what I think about this, but I think I want to try this at least.
Yeah.
Does anyone have thoughts about like having stuff like half the language is constant by default and not doing it everywhere? Because I know online people are going to be upset about that.
I'm fine with immutable by default and having to put syntax there to make something mutable when you
That's what I
initialize
did
it.
with AA. The standard assignment is immutable by default. The colon equals.
Yeah, but my thing is about private methods not have it by default.
So this one, for me, this is a final assignment. A is not allowed to change, and this is a mutable assignment. So just the colon says it's mutable, and you can change it again, and the first one says the value is not allowed to change. I'll let you assign 1, 2, 3 again. If I can prove it in the compiler that it's actually identical assignments, I'll let it slide. That's just a flow analysis on the last assignment to A there.
I think the answer to this question is the one that you pick will be the wrong answer.
Yeah, some people hate it no matter what.
Both languages, both styles. You code, doing it. No, damn it. And then you got to go through and chase and flip it over to the non-default. And it goes both with mutable and immutable. It's just one of those things because you don't think about it until something's going wrong, and then you want to chase it back and find the bug.
But you were saying that it's context dependent. You say private methods are mutable by default.
Oh, simple does that. In the constructor, all fields are mutable.
That makes sense.
When you leave the constructor, if it's been a final assigned or declared about in AA, not sorry, in simple, not AA. If it's been declared a value, you're allowed to assign it repeatedly in the constructor, but when you leave the constructor, it's now immutable. This is simple.
Leva, what were you saying for your language? What was the semantics? You might be on mute.
Yeah, we've had internet issues.
Wait, sorry.
Well, we were asking what are you doing again for immutable versus mutable? You have something constant values. You say constant, but we're thinking immutable.
For my language?
Yeah, you were just describing it, and we were going back and forth a little bit with what I was doing, and now.
Okay.
Sorry, I thought it was Levo that was saying that.
That was Levo. Yeah, I thought it was Levo. I don't have the people up.
Levo's disappeared.
I see.
Okay, fine. Okay. I think we just have internet issues. We've had them all day.
I can give some announcements for my language. I have gotten template variables and global variables working in the const per VM. So now I can run this. Let me paste it in the doc. Where's the doc?
Yeah, find the doc. I'm typing in one block, so go a different block.
Okay. So this is just like an implementation update, I guess. I can run this test in the const per VM now. So I have like a template, and it's a template variable, and it has an initializer, and then it runs that. Okay. It's not a very complicated test, but this has like lazy initialization. So I implemented like 4 instructions to get this working. I have like get global storage, and then I have init guards where I have like get init guard acquire, init guard, or like init guard try acquire, init guard release, and init guard abandon. And then there's like an init guard lock. So basically similar way C++ does like function level static variables. And then it'll probably have the same implementation in the machine code as well as the C++ version. But I can run this in like a const per test. I'm thinking of doing this thing where I introduce like this concept of like ghost and mortal variables because I've figured out there can be like variables that you might declare that you probably don't want in your like const per context, right? So like maybe I want to have like I don't know memory mappings, and then this could be like a mortal variable, which means that you can't like access it during const expr. I don't know. It's like a map type.
Yeah, you have terrible syntax or names or something, sir. There's enough confusion going on here.
So which part? Like mortal. So mortal would be like a variable that only exists at like native code. And then you could also like I was thinking because like let's say I have like I don't know like linked Zor link list, right? I have like Zor link list class, okay. And this has got like we've got like dot nodes, which
Well, no,
is
I
a
mean, I
var.
mean things like why not just do class of Zorlink list as opposed to colon Zorlink list class?
Just makes parsing easier. Then I could just have like if I want to, I was this originally was thinking about like anonymous functions, like I would maybe like want to be able to just like equals function or something. And I was thinking, okay, that was the original reason, and then also like nesting like templates together. I felt like this. mm, it's unusual, but yeah, I feel like this is a little bit more consistent. Um. So anyway, so I've got this like I don't know value var t, and let's say that this is the template, right? Template, and it's I don't know like t, or I guess I could just use auto t here, make it positional, right? Okay.
Yeah, I'm back to the syntax change just causes confusion without helping understanding. Um,
Okay. So I have this, right? Um, so I
you
have,
were okay, fine, go ahead. Sorry, I
but
just sorted out what happened with the question about const expers.
so I have this, but like here's the problem with this, right? I've got node and then I've got value, and this is like a Zor linked list, but you can't really do like integer pointer like operations in const expr, like into pointer and pointer to int. This doesn't really work in const expr. So my thought was like, okay, what if we can solve this by like adding dot left.
No, I don't understand your problem. So nodes as a uint pointer, what is the goal there?
So like, do you know how Zor linked lists work? So
Yeah.
like you say like the left is the so like the address of nodes is like the left node Zor the right node, a
Hmm.
pointer. So you've Zor the two pointers together. So if you come from the left node, you know what the right node is because you just Zor it with the pointer, and then you have the other one.
Gotcha.
So that this doesn't work in const expr because you don't do like pointer to integer and integer to pointer conversions in const expr. So my thought was I could do like left,
But
and I could
why?
do like
Why
ghost
not?
var. Well, because you can't. Like, how do you implement this in const expr?
Well,
Like
you have to
with
actually
provenance.
you have to actually put a value down for the node. Now you have an address for the self, and you have an address for the other guy, and you're just running it ahead of time.
Yeah, I mean it
Yes,
breaks like the
you say const expr
provenance
and I say
tracking.
const expr. Maybe we have a conflict here. In my head, const expr means I'm just going to take this shit that you're compiling up, and I'm going to turn around and evaluate it directly.
You would have to track the provenance, and provenance is an abstract symbolic value. So if you have like a pointer plus one, you have to remember that it takes the provenance of the original pointer. But what if you have a pointer plus one minus one? Should it go back to pointer or not? These are actually questions with optimization implications that are unpleasant.
Oh, with optimization questions.
Well,
Yeah, because
also
you
just
don't want to do constant folding at compile time, obviously.
Right.
yeah, yeah. It's hairy. So my thought was okay. Like, what if I just do like left, and I have this like ghost var, and then that's a pointer to Zorlink list like that, and then I have dot right. and it's also a ghost variable, and it's also a pointer to Zor linked list. And then these two variables only exist at compile time. So like they're not members of the struct when you're evaluating it at runtime. So you could still take this type that has like this type does something that is not able to be done at compile time, whether it is like, I don't know, it runs an assembly routine, like it runs code on the GPU, like it does something in a way that the const_expr VM just cannot handle, and it affects the layout of the structure such that it is not possible to do the thing that the structure does at compile time without like adding fields to the structure. But you don't want to add fields to the structure because that would make the layout less efficient significantly. So my thought was, what if I create these like ghost variable member variables that only exist at compile time? And so you can use the less efficient algorithm with a branch like a runtime branch. It's like runtime const_expr do this, runtime native do that. But also you can change the struct itself with these ghost variables to add fields that don't run in native, like they don't exist in the size of the struct or in native code at all.
Yeah, somehow you're missing your elegant solution here. There has to be a way that doesn't.
So it's like, so like if I'm on like, I'm on a node, I'm like, so I have like, I don't know, dot next function, and then I have, let's say add previous, and that's going to be a pointer to Zor linked list, right? And then, so in the native code, I would say runtime native, right? I would say that this would be like prev as uint pointer Zor, that's my Zor operator, dot nodes, and then we'll take all this and we'll say return all this as, and I don't remember what the association is, so I'm just going to put parentheses around here, and I'll say I'll return that as like Zor linked list pointer. Okay, so you can see that this is like a native expression. It's like it's taking the pointer that I pass into it, and then it's Zoring it by that nodes, and then it's taking that back. But I can't do that at const_expr. So I could say in const_expr, I could say if dot left equals prev.
I mean, I understand I understand that you're trying to allow this thing to happen at compile time. That's the const_expr, and you're adding two different implementations. But I don't understand why you wouldn't just be able to do this at compile time directly.
So why you can't do uint pointer? So okay, let's imagine for a moment. Okay, let's say that you've for some reason you've decided that you have a way to do pointer to integer and integer to pointer conversions in a way that makes sense at compile time. Okay, now what if I need to run something? What if I have something that does like a SIMD multiply using some GPU acceleration, and it's like GPU handle ID and execution unit, and then I have a single assembly instruction that runs some, I don't know. Okay, but just assume somehow for some reason there's something I cannot do at compile time, and it requires more data in my structure to do the thing at compile time without those like native runtime facilities.
That's what I'm getting at here. So I guess I'm not understanding the problem, the sort of stated problem of I'm making up a data type. So I would go to Zor linked list, but I'm making up a data type. I'm going to make an instance of it at compile time. I'm going to make maybe several of them on a linked list, whatever, and I'm going to chase the linked list. It's all statically known. Like if I'm a game writer and I have a linked list of things that happen to represent static elements in the scene that aren't going to change, and I want to go run them down at compile time and optimize for them, assuming that they're starting out some constant way. So I have to have some constants to begin with. Like, hey, I have the Zor linked list template here. Well, I'm not doing anything as a const_expr unless I got a const one of those. So somewhere in the world, I have a constant Zor linked list, and I want to say, give me the next field. And then somewhere in the next field, or the next, I'm going to stop and say, I now do a thing that I only can do at runtime. I can't do at compile time. So open a file system, do an internet search, something I can't do at compile time because other things aren't set up. How far can I run the const expr until I hit this point which requires me to actually do it at runtime?
Well, the entire evaluation context is either const expr or runtime. So like if I declare a variable, right, and
well, that's what I'm saying. You're adding this distinction. The entire evaluation context is one or the other. I think that's
well, here's the example. Here's the example of like a const expr evaluation context. So it's like var x is foo count of int of I64. This is a const expr evaluation context. I need to know the result of this expression to know what the type of the array is. So this is a const expr evaluation context.
Okay, so I right away I don't know what your syntax means here because you invented a syntax. So
okay, so this is like so var, this would be like var 4 I64. That's a variable containing like an array of 4 integers.
So it's
like
an array of 4 integers.
Yeah. So the above one is an array of whatever the return value of foo is.
Right. But integers. Now you want a const expr foo.
Yes. So it can evaluate any like just like in C++ you declare things const expr. In this language everything is just const expr unless it's not const expr. Basically. So like you can't call assembly routines, like it'll be a const expr evaluation error. You can't.
What is the issue here in that sense? Foo has to be evaluated completely, and if it cannot, you should have a compile error. Foo says, my value is equal to read the command line at runtime. Well, you can't read the command line at compile time, so compile error.
Right. That would be a compilation error.
Assuming. Yeah, right. So assuming I can compile foo. So now I need to evaluate all of foo as a constant expr.
Yeah. So let's say foo does some algorithm and it uses a linked list in that algorithm, and that type doesn't let's say
to make an algorithm that uses a linked list, I have to have a linked list. To have a linked list, I have to have an element. To have an element, I have to have a concrete value at compile time. So I better have a const expr concrete value at compile time.
Yeah, so you could imagine you have like foo function, and then it's like, okay, var.
Just grab the third element out of a linked list. Grab the third element of a linked list. Just go, next dot, get the value. So here you're building the linked list.
Yeah, and then it's like, okay, I don't know. So I say x auto y equals dot begin, and then we can say plus, and then I guess.
Yeah, but just be done. You pick one of the elements out of the list and return it. That's your constant value. The issue is you have to make a constant linked list, a compile time known linked list for 3, 4, 5. It seems entirely plausible.
Right. And so anyway, so it's this next operation. You get into this next, and then you're trying to cast. Just take my word for it that integer and pointer to integer conversions in const expr is hard.
No, I don't.
I wouldn't say it's impossible to implement, but
I don't. I wouldn't do a Zor linked list because I wouldn't let you cast an integer and a pointer. I wouldn't let you Zor and then go back to being a pointer because that asks for trouble in terms of type safety and a safe language. But if you're doing C++ and you don't care, it's fine. But I don't take it as hard. This is not hard. Somebody makes the implementation at compile time has to match the implementation the compiler is generating for your runtime. So that the semantics are equivalent. Then he generates at compile time your structure with this linked list in it, and then he does the code that he's generating for. He just runs the code he's generating.
Yeah, so that assumes your model is a sandboxed virtual machine as array of bytes, whereas I'm doing this as provenance based lifetime tracking.
All right, maybe there's a difference. I would claim if I'm going to do this, and it's kind of a thing that runs around because the GPUs all want to do these things. Yeah, I would just say, sure, I have semantics. They're well defined. Either I'm generating the semantics or I can have them in-house and run them directly. This is in
Yeah, so
simple, I would interpret the IR directly.
One of the problems here is like there are language rules like provenance tracking that I want to be caught, like provenance errors to be caught at compile time.
Mm-hmm.
And so I don't want to introduce things that bypass the like pointer to integer casts require like completely bypassing like provenance rules because like it's like how do the integers carry provenance? And
Yes, because you have no provenance here.
Yeah, as soon as you gave up provenance, as soon as you try to cast back to a pointer, you've lost it. So why did you cast back to a pointer? Why'd you cast away from a pointer? I think the XOR part just makes your life harder. Make a linked list as a normal linked list for the
And it
compile
uses an
time
extra.
folding.
Yeah, that's what I'm saying. It's like for the so what this would allow you to do is it would allow you to have essentially two different versions of the structure. So the type has a version that runs at compile time, which is this left and right version.
Yeah.
And then there's the native one that's doing the.
Right. As soon as you have two versions of things, they get out of sync and you break subtle bugs. It works at compile time. It fails at runtime because they're just out of sync. This is not a strategy I would take. You're welcome to do it. I'm not going to go there. I think you're asking for trouble. You invented a trouble for yourself, and now you're having trouble.
I would suggest if you're going to have two versions, give them two distinct names because they're not going to cross over the compilation to runtime boundary. Yeah. So what's the point in having one item with the same name? Just underscore compile, underscore const or something like that.
Yeah, right. I'm with you, Dan. That's a good solution here. Break it apart. You have two different things. One where you never get rid of the pointer provenance, so you can do it at compile time, and one where you allow the user to have a faster version at runtime that can lose the provenance. Basically, go int pointers and ints and pointers.
I see this structure all the time, especially in functions, but they're also in classes. I call them schizophrenic functions, schizophrenic classes. You put them into a situation, and for some reason, they're totally off. Nope, they're going in a totally different direction. Why? Because you passed in a slightly different parameter, and it's got a special value to it. No, name those things, keep them separate.
That's an interesting whole design philosophy there. As soon as you have a function which essentially is going to do two different things based on some particular argument, you should just make two different functions and be done.
Oh yeah, you can see it. It's you just go look at the body. If this do a whole bunch of stuff, else do a whole bunch of other stuff. Okay, let's lift that out. Don't do that.
Yeah. In fact, that was just recent last thing I did with Hashgraph that was causing me more trouble was they had a function that had a three-way of those splits. There was an if cutout, don't bother, but then it had an if this, go A, else do B, else do nothing. There were three ways. It was A, B, or nothing. And I broke it out into three parts. And then I had to hunt down all the different little places where they came in with ambiguously, whether it would be A or B, but every call site eventually settled down to one of the three choices.
Yesterday, I actually just wrote a function that is schizophrenic. I can't say that word.
Yeah.
So, but I think it was okay in this case, but it's been a while since I did something like this. So my print function has a styling, and each style is completely different implementation. So instead of like calling three different functions, I'm like, they're only like 10 lines each, just have it all in one function. But yeah.
And for prints and debugs, I kind of get a little more loosey-goosey in general. But for code, I'm keeping a long time. I'd like to believe that I don't write schizophrenic functions, but I certainly have seen plenty of them. And I won't claim I'm not immune to writing them either. I'm definitely think that's a good theory to go clean those out. All right, I'm going to start wrapping up here.
I was gone for like maybe 20 minutes, maybe more. Did we talk about if it's a good idea to have operator overloading in general? Because I like them. A lot of people would rather have everything as a different function, like a function name. And I don't know. I really like overloading.
We didn't talk about whether or not you should or should not. there's definitely camps of people who badly want them. So physicists are being one of those, where they're doing matrix multiplication games and they want to have their own
I am
definition of an operator
100% in
overload.
the yes. You must have them. A language needs them. If you do not have it in the language, it is a major issue with the language.
So you said that, Ben.
Operator overloading is evil.
Yeah, exactly.
When I read code, I would like to know what it does. And this just means I never know what anything does.
Right.
You could say that about any function, though.
Yes. I suffer with it being functions, but when it's just the general syntax of the language, like, should we be able to overload the curly brace? Like, let's take that one away too.
Yeah, I didn't.
And the semicolon.
Braces. I couldn't come up with a parsable, non-ambiguous syntax if you had overloaded of any of the groupings. I could get away with it on square brackets because they only otherwise show up in arrays, but curlies I couldn't do a non-ambiguous syntax because I wouldn't know if I was looking at an operator or not. Like if I'm parsing this wad of text here, is open curly an operator? Well, that depended if something I ran up here defined an operator assignment for a curly, and then suddenly I have to parse this differently, and I couldn't do it. So
I'm not even talking about the compiler. I mean, like, I'll assume the compiler can figure out things that my brain can't figure out. Just as reading someone's code, having to always like double click in to see, like, wait, am I actually looking at an array or am I looking at something that doesn't have array-like semantics? Operator overloading is really cool and really useful. And like at the
that
end
argument,
of the day,
that argument sets with any feature in a language. Well, you shouldn't have ifs because I've seen nested ifs 300 characters deep, and you've got to. I'm scrolling across on a 4K screen. Like, why do languages have ifs? You don't just do polymorphism. Then you're done.
That's your argument that you could write read-only code, write-only code in any language.
Yes, you can do it. Yeah, give someone a feature, someone will do something stupid.
Yes,
but it doesn't mean that the people that use it properly and responsibly shouldn't have it.
I hear you. There's just like something about like I like knowing when I've reached like ground truth, right? So like the same thing with fields. Like if I'm reading a field, I don't want the implementer to be able to override the field read with a method, and all of a sudden a field read is actually 10,000 times as expensive. Although I get the beauty of being able to do that. So it's just like for me, I like to get cut off where I know what I'm dealing with without having to double click in.
But numerical code is much easier to read, though, if you do have operator overloading for matrices and vector. You can live with spelling out the functions like add and multiply, but if you have someone who works with numerics, like physicists, they really want those equations to appear exactly as in the physics paper. So they will just not buy that. They have to spell it out in English.
I suppose what I really want is an IDE that does proper syntax highlighting to let me know that I'm looking at a overloaded operator.
That should be doable.
Noted.
Yeah, this should totally be doable. Like if I've defined a new operator like
JetBrains does that.
Does it?
Yeah, if you've got a syntax highlighting, if you set your colors if you set your function colors to something different, you've overloaded an operator, it'll color it as if it's a function.
Okay.
All right. Then I changed my position. Last time I dealt with C++, JetBrains did not have a C++ IDE. So yes, given that, okay, I can live with it.
I got a question.
Red and squiggled, and I'll know.
So do you use colored curly braces to easily see the matches? Because a lot of people do. So I wonder what the solution is if you want overload to be a different color.
The rainbow colored code. Did you have to pick your colors to make your life easier? I mean, that's a user.
Yeah, what do you find important? You pick the things that are important to you.
Yeah, I think maybe if it's an operator overload, maybe just have it in one consistent color. But if it's not, it just be the regular rainbow color. But I don't know. People
I don't care. If someone's overloaded an operator and it's expensive and I'm running code, I don't care until it shows up on a profiler and I go, oh, probably have to look at that and see what it does.
And it's a matrix. Also, I agree. and it's 1,000 by 1,000 matrix multiply, and it has some real numbers to it. Yeah. So the other one about the operator overloading is the square brackets for dictionaries versus arrays. Like Python square bracket dictionary lookup is de rigueur. It's everywhere. And it's kind of convenient looking.
Yeah. Dot get was like just way too much to type.
Okay.
Also, like you can definitely, like, as it stands today, you can just overload operator overloading colors. Like on my IDE, I have it where if an operator is overloaded, it's pink. If it's a default operator, it's black. So it's like there's a pink plus sign. Oh, that's overloaded.
Right. That's what IntelliJ was saying. Somebody was saying that IntelliJ operator overloading would pick, if the plus here, it would get the function color instead of the operator color. And I assume the operator color would be black on white for me and white on black for whoever. But the function color would be different. And that makes sense.
And to be fair, we still have to think of people who do some crazy things like reviewing code PR on github.com, because that does not have good code reading interface at all. It's like going back to the 1970s with Vim. I think that's pretty much github.com code review interface right now, except Vim was probably better. Much faster for once.
I thought GitHub did an okay job of coloring Java code.
Yeah, I'm kidding a little bit. Yeah, it doesn't, that's highlighting, but it's so unbelievably clunky. I mean, if you have used proper editor, it's such a piece of... I'm gonna censor myself here.
Are you trying to share this opinion?
I have a screenshot below, a little lower in the doc of if you scroll down a little bit.
All right. Well, I want to wrap it up.
Microsoft Devs up.
Okay.
The Microsoft DevOps is even worse.
Yeah, you can see the pink overload on the function call operator because that has a overloaded like function call.
Okay, I'm missing pink. I have a red type is
bottom
unimplemented function call operator overload.
Yeah. Why is this an overload?
Because overloaded the function call or whatever. Let's see.
It's a function call with pink parens, but you have parens. I want to see the pink on the plus.
It's actually the that's the constructor. I don't know why it's pink. Oh, because it's a member function. That's right. So any member function, not really overload, but like it also does that. Let me see if I can find a.
Yeah. So I'm like,
but we can also all envision what a pink plus sign looks like.
Yeah, right. Here's the plus sign. Now go make it pink, Clifford. Right. Cut, copy, mock down. No, any colors up here. Here is. I'm going to do one more attempt and I'm going to give up. Highlight color.
You want to use the text color, but...
Okay, so I did something to color. It wasn't pink.
You just implemented operator overloading. This is amazing.
I know. Yeah. What are we doing here? Okay, wait. How about this?
I got to say that the one time I like... I forget what they're called. Properties. When you make a field a function call.
I hate those.
The one time I like them is when I read or write, but I want to break points when some kind of condition is met. So I typically write the condition to like a yes or no global variable, and then I want to break on it. But I can't do that. I have to either use a watch variable, which is all reads or writes, or I got to figure something else out. And I think one of the time traveling debuggers was pretty good at solving that problem. But for the most part, I only want properties when I'm just doing that one thing, breaking when a global condition is met.
I
use properties for immutability. If a function doesn't change anything, then you can make it a property, and like list dot first, it's just property on the list.
I have a question for Mark. Would you actually prefer an approach that OCaml uses for the operators when the floating point operators actually have to be different? So like have you plus dot, minus dot, star dot, slash dot?
Oh.
Because if you think about it, floating point division is a different operation than integer division. Sometimes you do want this to be called out.
Yeah, I suspect I would ultimately prefer that.
Here is a...
I have to say, there are pros and cons of this, actually, yeah.
Bruce, I also just try to avoid floating point entirely. So.
Oh, yeah.
That's cheating.
Yeah, I did a startup involving math, and he couldn't get away with... he had to do floating point.
I have been grappling with the monstrosity of floating point and trying to write a spec that works for my language. And I'm like, okay, IEEE, all of your rules are completely stupid, and operator equals is not going to work like that. And there's going to be a function called
you do not have a choice.
Equals.
Yeah.
No, I do. I do. My choice is there is.
No, the rules for IEEE are not stupid. They're very, very well thought out, but that still makes them annoying to use. But they're very well thought out.
But it's also even if your rules are better, they're not the rules.
They will be, because on my language, if you want that behavior, you're gonna have to call .IEEE equals as like an identifier, because like I'm not breaking like strong ordering on a basic data type just to follow some things that are useful for number crunching, because like it breaks containers and all sorts of stuff if like A equals B is false and then A not equals B is also false. Like that is unacceptable in every way, shape, and form.
And the question is, should you really provide equals for floats at all? Maybe the safe answer is you shouldn't.
Yeah, there you go.
The answer is you should, because you need to be able to stick them into containers.
No, you can't.
But you
have to go into ordered containers.
Yeah, it's a design question whether you want to. I actually like generic programming a lot, and I actually think you have to have generic programming in Stepanov style. Like you want to have hash table that takes generic T that is hashable, or you want to have a map that takes a less than comparable. However, I disagree that this has to be implemented by operator overloading. It's perfectly fine to have a separate hashable function, separate compare function, or separate equality equals for the sake of container function, spread however you like. You do not have to couple this implementation with the built-in language operators. So I speak as a fan of generic programming. I think it's a great idea for the design of containers to have this genericity, but I disagree that it has to be implemented by overloading the built-in core language operators. That's my distinction.
Well, my default is going to be that floating points are going to behave very regularly. So I also have to do all this stuff on nans, and then this like, okay, so I'm saying like if the
why would you support such a weird thing as nan?
Well, there's got to be. I have to like normalize the nans and come out with like a strategy
wait. No, you don't allow any nans in. You don't produce any nans out. Just say no nans.
Well, there are operations that produce nans.
But
what
why?
am I going to do? Insert a
runtime
check?
Why would your operations produce a nan?
Nans can be useful, actually. There are so many things you can stuff in nans. You can even use them for tagging.
I'm going to call it. We can argue the floating point semantics until the dawn of time, and next week. Also, we can argue them next week.
Okay.
But this is like a no-end rabbit hole. So I'm gonna.
I mean, floating point numbers. It should take 5 minutes. We should wrap this out.
Yeah, exactly. Right. No. You're not catching me with that one. I know better. All right, folks. Very entertaining. Until next week. Bye-bye.
Bye.